Welcome to this video lecture about the book Scientific Research in Information Systems. This video lecture is based on a book with the same name, Scientific Research in Information Systems, published by Springer, second edition, 2021. This video lecture is part of a multi-part lecture series on one of the chapters of the book, Computational Methods. In this particular video lecture, we will discuss computational support, augmentation, and automation tools. Just as a refresher, as an overview, with computational methods, we mean methods that support or carry out research processes such as data generation, discovery, processing, cleansing, analysis, or interpretation through algorithmic software tools that provide computational capabilities. And if you contrast computational methods to other methods for doing research, such as empirical methods, qualitative methods, and quantitative methods, or design methods like design research methods, where quantitative methods have, so to speak, a focus on numbers, and qualitative methods have a focus on words, so to speak, and design methods have a focus on artifacts, you can think of computational methods as having a focus on digital trace data. And in a separate video lecture, we discuss this set of digital trace data. In this video lecture, we will discuss different forms of computational methods that either support, augment, or automate research processes. So what we mean here are software-based techniques and tools that have in common that certain steps in the research process, data generation, processing, and or analysis, are carried out through or with the help of algorithms that either augment or fully automate an otherwise manual activity in research. So computational data processing and analysis tools are pieces of software that researchers can draw upon in one or several stages of the research processes, generating data, processing data, analyzing data, either to support their manual research activity or to actually take over and carry out this research step automatically. One way to think about this is if you just contrast that in some sort of matrix, where on the x-axis you have the different steps of the research process, from generating data, processing data, and analyzing data, very broadly conceived. And then on the y-axis you have the different forms of computational assistance, from support to augmentation to automation. Now, as you can see here, I'm drawing a line and I'm graying out computational support tools, because in a narrow sense, you could say that these are not computational methods, because in computational support tools, we will use software techniques to support a fully manual activity. So this is basically classic research, where instead of pen and paper, we now use, apps or software tools. But computational augmentation, computational automation are, in a narrow sense, true forms of computational methods. But in a broader sense, of course, you can say that computational support are also computational methods. So it depends a little bit on how you see it. And as you can see here, I would encourage to use a more narrow definition. When you talk about computational methods, we typically mean research carrying out through software-based techniques and tools that augment and automate research, as opposed to just supporting an activity that we could have done manually. So to highlight this, the traditional computational support tools assist research in carrying out their research work through computer software. And we've had that for a long time. So the important point here is that these software tools do not carry out any of these research steps themselves. They don't do any of the research steps, but they assist us in carrying them out, in the sense that we can make it complete these tasks a little bit easier, faster, more consistent, and more convenient. A very traditional tool that most students learn as part of their studies are, for example, software statistics packages, SPSS, R, Mathematica, or maybe even Lizrel, Atlas, NVivo, Nudist. These range of software packages that have been developed for researchers to do things that you arguably could do otherwise. So, for example, in qualitative research, you could code using pen and paper. And in quantitative research, of course, you can carry out statistics, using pen and paper or a calculator. But people have developed these types of software packages to make it a little bit easier. But the agency over these steps is still with the researchers. Similar, we have seen a rise of tools that are not necessarily developed for research purposes, but that are proved to be very helpful during research. For example, typically we would have done qualitative interviews with a simple recorder, right? An interview recorder that would put on the table and do the recording of the interview while we talk with people and have pen and paper next to us. Over time, we started using our mobile phones because they do have interviewing capabilities and recording capabilities. But at the latest, since the onset of the 2020 pandemic, most researchers carry out their interviews using video conferencing tools like Zoom or Microsoft Teams or Google Meets, these sorts of tools, because they have interviewing but also video recording capabilities. So they can, very hands-on help us in recording the interview, for example. And of course, it allows us to actually be physically distant. We can interview people at work while not being at work, which is very nice. And, over time, for instance, since last year at the latest, some of these tools even now have better capabilities for transcription services. So while you're talking, it starts transcribing everything to a reasonable degree, right? So back in the day, usually you would have your audio recording and you have to transcribe it into text, or you could use a paid service for that. And now we even have algorithmic services, some of them paid services, but even, Teams and Zoom, they have decent transcription services for free. And some of them even, if you think about it, you can also use online translation tools. Let's say you do your interview in German and you want to translate it into English. So all of these we would classify as computational support tools for data generation. Yeah, recording interviews, for example, or if you think about SurveyMonkey or Lime surveys or Google Forms, these are survey development tools, very easy, digital, online. And of course, for computational data analysis, qualitative, quantitatively, and so forth. They don't do any of the work, but they help us. They make it convenient, easy, fast, and and sometimes even more consistent. Computational augmentation tools, as I said, this is really the realm where we get into the true meaning of computational methods. Are software that we use to complement and amplify human activity rather than to supplant it. What that means is that we use computational software tools that allow us to do something that would complement our research activity and maybe amplify to the point that we can now do more volume, more things, more productive, like more of that, in the same period of time and so forth. Yeah. So when I talked about Teams and Zooms and other video conferencing tools, this automatic transcription service, if you think about it more as an augmentation rather than a support tool, because that is actually amplifying, complementing activity. This is actually doing it for us. It's not supporting us in doing the transcription. It really is doing it for us. So, maybe it was poorly placed as an example beforehand. Other examples are web scraping, web crawlers that allow us, for example, to harvest all the tweets that have been, put out, or that allow us to scrape all sorts of documents that match certain filter criteria from a range of websites. Think about someone that scrapes all the press releases from a number of Fortune 500 companies or something like this. This complement and amplified human activity. It doesn't supplant it. That means like, theoretically speaking, we could do that manually, but probably not to the extent that we're actually using it. So for example, if I use a web crawler or web scraper, I can easily scrape or crawl millions of documents. Now, could I do this manually? Theoretically, yes, but practically speaking, it would be next to impossible, very unfeasible, right? So I could do the same thing manually, but would probably be limited in volume, in scope, in time frame, anything like that. But of course, with computational augmentation tools, I could, for example, browse, scrape, crawl all sorts of web archives going back over, decades, for example, right? So this would then be an augmentation tool rather than a support tool. Yeah, same with Teams, Zooms, and this sort of automatic transcription. Can I do this manually? Sure, I can pay someone to do it. For example, I can do it myself. It takes me a long time, and thereby I'd be limited in either by my time or my money. But the augmentation tools, like the fact that I have automatic transcription services, allows me now to, do as many interviews as I want and automatically have them transcribed and or translated. So one example for such an augmentation tool is if you think about some statistic software packages. Lizrel is one example. Some others do it well. When you analyze your data statistically, what this tool already does is as you analyze and you check for those regressions that you expect in the data. Yeah, a hypothesized model that fits the data. It checks for that, of course, see how well it fits the actual data. And then based on its own analysis, it automatically makes suggestions for respecifying your hypothesis, your theorized model that would actually better fit the observed data, right? So it basically says, look, you know, this error that you expected isn't actually there, but there's another error here that you didn't think about, yeah? So you can implement these suggestions or not, yeah? They may not be conceptually logical or plausible. So it's not that this automatically takes over the interpretation of the research process, but it augments it. It helps you to see something and, you know, analyze and expect something that you may or may not have seen otherwise yourself. And finally, the third step are computational automation tools. You can think of these as software tools that carry out data generation, processing, analysis algorithmically with little to no human intervention oversight. So autonomously, so to speak, automated and autonomously. Yeah, so here we have software tools that actually carry out generation or analysis or interpretation algorithmically without you doing it, without helping you, doing it for you, so to speak. And there's a couple of these examples. So for example, you can run automated software network analysis over a bunch of person relationship data. And, you know, and it finds out, you know, who are central people, what are the connections, who have friendship ties, you know, whatever else you want to find about social networks. Text mining algorithms automatically extract information from text through algorithms that parse text, classify text, derive patterns in the text, and even tell you what the text is about. Yeah, so they can define the latent semantics, sort of the meaning of the text algorithmically without you having to read it. Machine learning algorithms, they can find patterns, relationships in the data that you would be unlikely to find manually, right? So they are discovery data or pattern discovery algorithms that find patterns in the data for you, so to speak. And these are the three forms of computational methods. And as I said, support methods, strictly speaking, are not computational methods in the narrow sense of the definition, but augmentation and, of course, especially automation tools are those that we classify as computational methods. This brings us to the end of this brief set of video lectures. And the next video lecture will give examples for these different types of tools. Thank you for watching, and thank you for listening.